Hello guys, how are you today? In this video, I'm going to revise with you the difference between covalent and ionic bond and some general questions about how to solve the dot structure for some compounds. As negotiated before, we have covalent bond and ionic bond. And as you can see in this table, it depends on the electronegativity difference between atoms. So if the electronegativity difference was between 0 and 1.7, that means that we have a covalent bond. And remember that if the difference is from 0 to 0.3, the covalent bond will be nonpolar covalent bond. And if it was between 0.3 and 1.7, the covalent bond will be a polar covalent bond. And if the difference is more than 1.7, then we will have an ionic bond between atoms. The electrons in the covalent bond are shared, while it is moving completely to the orbitals of the atom that gain electrons in the ionic bond. About the strength, the ionic bond is stronger than covalent bond, as we said before, and the main unit in covalent bond, the main unit in the compound will be a molecule, while for the ionic compound, it will be formula unit. The chemical formula for covalent in the covalent bond or in the molecular compounds will be molecular formula, while we can't say molecular formula for the ionic compounds because it will be a formula unit or chemical formula. The compound name, as you know, if the atoms are bonded together with a covalent bond, the compound will be molecular compound, and if it's bonded with each other by ionic bond, we will have an ionic compound. Some properties of covalent bond or molecular compounds, usually they will be gases at the room temperature and soft with low boiling and melting point, while the ionic compounds will be hard and brittle, and most of them are solids at the room temperature, and they will have a high boiling point and melting point. This is a general information about the covalent bond and ionic bond. And now let's go to our main part here in this video, which is how to draw the dot structure for some compounds. Let's start with a compound like CO3 minus 2. I hope guys you have your copybook now and your pen and write down the steps how we gonna to draw the structure, and try to draw it by your own before see the solution here in this video. So what is the first step here? First thing, we have to count the number of valence electrons for each atom. So for carbon, we have 4 electrons, and for oxygen, we have 6 electrons per each oxygen atom. And here we have 3 atoms of oxygen. So times 3, which is 18. And we have the minus 2 here. It means that we have an extra 2 electrons. So we have also 2 electrons. Now, the total electrons will be 24 electrons available for drawing the dot structure. This is the first step, counting the total number of valence electrons available. Second step, we said that when we have carbon, then carbon must be the central atom. And if we don't have carbon, then we go to the less electronegative element or atom and consider it as a central atom. So carbon will be the central atom. And we distribute the 3 oxygen atoms around carbon. O, O, O. And we put one bond in each side. So we have 3 bonds. Each bond is equal to 2 electrons. So we have 6 electrons now. So 24 minus 6, because we used already 6 electrons, so we still have 18 electrons. Now, after distributing the bonds around the central atom, we have to distribute the total number of electrons that we still have for the less electronegative elements around the central atom. So we have to distribute the electrons here around oxygen. So we give 6 electrons for each oxygen atom. And in this case, we used 18 electrons, 6 for each. So minus 18, 0. Now we don't have any more valence electrons. Now, if you look at the shape, you will find that oxygen is stable, while carbon is non-stable yet, because carbon surrounded by 6 electrons only from the bonds, which means it doesn't reach the octet rule, which means it is not stable yet. So what will we do? We will take 2 electrons from any oxygen atom here and remove it to form a double bond. So a new bond will be formed here. Of course, we could use these electrons, or we could use this atom, or we could take electrons from this atom. You are free to choose any oxygen atom. So the compound will be C double bond O, O, O. This is the Lewis structure, and we don't draw the dots or the non-paired electrons here, the non-shared electrons. So we could have this shape, or we could have, if we use another oxygen atom, we could have this one, or we could have this one. It is all the same, and as we said before, this is called resonance. Another example. What if we're going to draw CH2O? Same thing. Carbon will be the central atom. Then we have to draw H with bond, and O and H with bond. So carbon, 4 electrons and 2 H's will give us 2 electrons, and oxygen will give us 6. So the total number is 12 electrons. Minus 6 electrons used, we still have 6 electrons. So we have to distribute the 6 electrons around the other atoms, not the central atom. Remember, hydrogen is already stable because hydrogen cannot use more than 2 electrons, or cannot have more than 2 electrons. It is an exceptional case from the octet rule. So 6 electrons will be distributed around oxygen. So oxygen is stable. But as you can see again, carbon contains 6 electrons only around it. So we have to take another 2 electrons from oxygen here and form it to bond. So the compound will be C O H H. This is the dot structure for CH2O. Third example, NO3 minus. Start with counting the valence electrons. We have N with 5 electrons and 3 oxygen atoms. 3 times 6, which is 18 electrons. And we have the minus 1 electron, the charge here. This charge means that we have an extra electron, so 1 electron. So the total will be 24. Then we said that here we have to look to the less electronegative atom to be central, which is clear here. It is nitrogen, is the central atom. O, O, and O. So we used now 6 electrons used, so we still have 18. Distribute the 18 electrons around oxygen. 6 times 3, we used 18, so the total is 0. So we don't have now any more valence electrons available. And at the same time, if we look at nitrogen, we will see that nitrogen is non-stable. So what should we do here? Same previous case, we have to take electrons and turn it to a double bond. So the electron will be the electronic the dot structure will become double bond with O, and here we have O and O. So this is how we have stable nitrogen atom. Or as you can guess, N double bond O here and O and O, or N double bond O, O, O. Same yes. Okay guys, so this is how we solve it. And remember that we have double bond and triple bond and single bond. This one is the strongest one, and this one is the longest. And weakest one at the same time. This one is strongest, and at the same time it is the shortest bond. Another example, final one, ClO4 minus. Chlorine contains 7 electrons, and we have 4 oxygen atoms. 4 times 6, which is 24 electrons, and we have minus 1, which is 1 electron. So the total is 32 electrons. Chlorine will be the central atom. Then 1, 2, 3, 4, oxygen, 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 oxygen. Now we have 8 electrons used, so minus 8, 24. Now 24 electrons available, we have to distribute the 24 electrons around oxygen. Now we don't have any valence electrons yet available because we used 24 electrons. So 0. As you can see, chlorine is stable and oxygen is stable, so everything is all right and no need to use any other double bonds here. What about NH3? Nitrogen contains 5 and we have 3 H's with 3 electrons, so the total is 8. N, H, H, H. We used 6 electrons already, minus, so we will have 2 electrons. Now in this case, the atoms around the central atom are all stable, because hydrogen, as we said before, can have only 2 electrons, because it contains only one orbital, which is S subshell. So it is stable. So what we have to do with the 2 electrons here? In this case, guys, if the whole atoms around the central atom is stable, even if it was with the octet rule and contain 8 electrons, if it's stable all and we still have electrons, we put the electrons here over the central atom. And in this case, we will have non-shared pair of electrons. Hope you got it, guys, and hope you resolve the questions again and test your information. Thank you and be safe.